Hello, all everybody out there who's watching. This is Rehearsal Pro development, porting to Android using Kotlin Multiplatform Mobile, and rewriting portions of the iOS side that already exists. Originally written all in Objective-C and Swift. I've been slowly retrofitting pieces of it into Kotlin Multiplatform Mobile as I port over to do the Android side. Anyone who's been watching this stream of just raw programming, basically I'm just running the video while I'm working on this task. I've been on a singular task doing a rewrite of a major chunk of it to solve a bug. And I've been working on it for months, which is kind of ridiculous, but this is also something I've only been doing part-time, but I'm planning on ramping up to more full-time work at this point. So you may be seeing a lot more of these videos coming forward. The previous video, one of the viewers commented, Kotlin, question mark, question mark, question mark, because the entire video was simply covering the work that I was doing on the iOS side. And the title of the video is Kotlin Rehearsal Pro, Kotlin Multiplatform REHKMP. What is the title of my videos? I don't even remember. And that's a good question. So here's the Kotlin side. Since that video, I actually did another video, but I'm just going to trash that one. We'll post this one up there. And I also did some work off video, as you can see here as part of this task. If you've been following, basically I've been taking a lot of this code that was originally written in Objective-C, storing its domain objects using core data, and I'm replacing that with simply storing the backend JSON in dictionary form as it comes in and not putting it in the database so that it's more portable to the Android side, and using an ORM is kind of pointless. Also, this project is part of my overall FP MOB, however you pronounce it, initiative, which is functional programming for mobile. And this project, I'm taking an approach of developing using entirely a functional programming approach. As you can see, these are just functions. They are not methods of any class. And I'm doing that both on the Kotlin side as well as on the Swift side. And you can see that here. So we have standalone functions, and we have mere data structures. Data and functions are separate. This is functional programming. This is not object-oriented programming. And in a lot of ways, it's not really even procedural programming, because I make a pretty strong attempt to make as much of the code as I can in the form of pure functions. And I do that at the top level. This is Swift. Obviously, this is all new code that's been written in Swift. So you can see I organized the code here in the project. Originally, the project was a little more scattered. I cleaned a lot of this up. I moved all the original code under, I put everything under source. This makes it easy to find rather than having it smattered in various naming directories up here. I also like the fact that it sorts down to the bottom. So the bottom of the tree is the thing I'm focused on the most. Most of this is just housekeeping that you have to do inside of any iOS app. It's not really particularly useful to be looking at this point. And this is all stuff from before, legacy, with the exception of the shared pod, which I'll cover. So the source is all down here under source. It also makes it nice to be able to search this directory. It makes it easy. I'm going to go ahead and minimize the emulator. We don't need to see that. But when I want to search through for things, I use a shell script that I've had forever called findgrep. I can use the IDE, but the IDE, well, for starters, when you're doing development on multiple platforms, you have two sets of IDEs, and of course the tooling and the commands and all that work completely different. So it's really confusing. So I tend to stick to using my command line utilities. I like to edit in Vim. We'll come back to that. But I tend to use findgrep, which is a kind of a recursive grep. And if I want to look for something, I can just be in here and I can say, let's look for dictionaries. And I'll get rid of the first letter just for capitalization. And I can see all that stuff in here. And it doesn't have to search through all the binaries. It's very quick because all the source is in here. All right, so actually if I say find dot, you can see these are all source files. There's no binary stuff mixed in here. Oh, wait a minute, I think I saw zib. Is it zip binder or is it XML? I can't remember. Anyway, so back to this. So it's easier to look at the project. Again, we're looking at the iOS side. I'll show you the same thing on the Android Kotlin side. But you can see I have 3 categories of source here, 4 categories of source. I have dead. This is code that is effectively dead. It's old legacy code that I've been able to eliminate. This is the legacy code, which is split into 3 categories: Objective-C source, Swift source, and stuff that's neither. These are zip files, storyboard and zip files. And then main is all the new code. So ideally, at some point, it'll all be under main. And I always separate for functional programming, whatever the top tree of my source is, or the top main directory in this case, I break it down immediately into pure and side. I find the most important distinction from the top is I want to know what code is in pure functions and what code is in side affecting functions. And a lot of other functional programmers don't make this separation. I say functional programmers really don't like categorizing people this way. When we're doing functional programming, you don't often see this sort of top level separation, but I like to organize the code this way. And you can see it's the same thing over here. So here's what the Android project looks like. Let me get rid of this so you don't have to see it. Right, I mean, these IDs are somewhat parallel. Project here is named Rehearsal KMP. This is actually the top level project. The original iOS project is a sub-project underneath that. It's Rehearsal iOS. So when we're looking at this over here, actually, if we look at the directories, and again, this is kind of my directory stack. This is the top level of the repo, and you can see we're under Rehearsal iOS. This is the same directory structure as the original project. So in some ways, this iOS project doesn't even aware of the fact that it's a subdirectory within its overarching Kotlin Multiplatform project, is what we're seeing here. And instead of saying originally the typical directory structure you'd see for a Kotlin Multiplatform or a KMM project is you would see Android, iOS, or Android app, iOS app, and then shared. But a couple of things happened there that I don't really like. Wow, that is a really big looking flying creature outside my window. You can't see it, but it's huge. But I like to prefix it with the actual project. I prefer all lowercase directory names in all directories that I use. I'm really not a fan of mixed case. I like keeping short names. And also like that these sort together. So I can see here's Rehearsal Android, here's Rehearsal iOS, and here's Rehearsal Shared. Right? And so I changed the names from the standards. I haven't changed these. These typically follow the standard. And again, look at how this kind of sorts weird. You got Android at the top, iOS at the bottom, and Common in the middle. Not a big fan of it. I also prefer to keep the tests and main code separated. So I would at the top probably separate main and test, just like I did over here, right? Main and test. I understand the logic here of making this more modular, and the Android and the tests go together, but you don't really, because you can't build this without the common. You can't build the iOS without the common. You could build one or the other. You could build the iOS without the Android, but of course you're not going to do that in a project anyway. But ideally, most of the code in the Kotlin Multiplatform is going to be under common. And you can see there we go. Common main looks just like main over here. My first breakdown is pure and then side. So we see pure because it's sorted at the top, also a 4-letter directory name. I like the symmetry there. Pure side, pure side. I know what I'm looking at. And everything in here has to follow the rule that it is a data structure. In the case of Kotlin, these are classes, but data class is the closest thing you can get to a non-object oriented data structure. Along with, so these are standalone functions. Turns out that I just turned my constants into functions. Why not? And domain and all this stuff here is all pure. Now, there's nothing in the language of Kotlin, nor the language of Swift, that's going to make an enforcement that these are pure. So this is purely, no pun intended, discipline on my part to make sure that I put things in the right place. And then everything with side effects is going to be down here, as we can see. I don't like a lot of files, so I tend to prefer to have more code and fewer files than lots of files with small amounts of code, as you're typically going to see in projects. In fact, if we look at the legacy code here, you're going to see how many files we have for even individual concepts, particularly in the core data. I find this particularly irritating. Right? I mean, look at all the individual files there. You know, we have a domain object called script, and it's literally broken across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 separate files for a single concept. And this single concept is split between header files and implementation files. Of course, this is Objective-C. By the time you get down to Swift, you don't have that separation. But we're still seeing this breakdown, this isolation of groups of functions because of the way the object-oriented features of the language and the way that they're being used. I'm not a fan of that. I don't like it. I try to keep stuff a little more cohesive. In fact, you can look at my domain stuff here. You can see I've got multiple domain objects in a single file, which I find easier to track and follow, especially when these are, for the most part, there's no substance here. These are stubs to get into the Kotlin side, because the iOS code is able to use everything defined in Kotlin on the Android side, or the common side, the shared side between the two, except that Kotlin Multiplatform doesn't generate a Swift compatible definitions, it generates Objective-C compatible definitions. So this is the generated code that KMP generates, and these are all Objective-C definitions. So when you're using Swift code, you're actually going from Swift to Objective-C to Kotlin. And now the Swift code can act on, as an example here, the Swift code can act on, like, for example, this @mutant KT, right? So this is a function. This is a top-level function on the Kotlin side. I'm going to close this down. So we go to @mutant. Let's see, what's the name of it there? Call with global @mutant. So there it is right there. Call with global @mutant. Now, this is not a class. It's really a namespace. And the namespace is automatically generated to match the file, not the package. So Kotlin Multiplatform approach will take whatever file name you have, any top-level functions and other declarations in the file are going to be scoped to that namespace. So when I refer to them in Swift, I have to prefix it with this generated namespace. And this generated namespace isn't really a namespace per se, because Objective-C doesn't have that. So if we actually look at it, we're going to see it's probably an interface. Yeah, there we go. And it even gets a generated prefix with the name of my shared project, and then they alias it to the name of the file so it can be used directly from Swift in this manner. And you can see this is an interface, and these are just top-level functions. So there's no instance here. There's no object, there's no class. And they can be called directly from Swift. But when, so functions that I have delegate, anyway, I'll come back, we'll talk about the shared facade at some point. The shared facade is a stub so that the Objective-C code can get to top-level functions without having to go through these interfaces, which are really, really problematic. Anyway, let me cover that. I wasn't really intending this to be a giant explanation of this, the architecture of this project and the strategy here, but in to treat the commenter who was saying this isn't really Kotlin. I don't see Kotlin. I'm doing this here for anybody who's watching this for the first time or wants to understand the explanation of this. I may drill into more of this. So for the rest of you who've already been following along, let's close this stuff out. What did I do since you've been gone? Well, we have this scroll pause class. I just keep staring at this giant bug flying out my side of my window. which you can't see because I don't have a camera on, and you can't see the camera. So just imagine a flying insect about the size of your hand trying to get in here and attack me. Let the cats get out and have the cats have their way with it. So where were we at? I've got a little background music. I don't think the mic's picking it up. I'll turn it down a little bit just in case. I guess that can be annoying. Right, scroll pause. Scroll pause is a legacy Objective-C core data class that we have moved to the dead folder. Here it is, scroll pause, so we can see all the files having to do with that. It's a scroll position for scripts and scenes, well, for scenes specifically. And there's a lot of them. And the original app stores it in core data, and that was a problem because I had moved out two other core data classes, specifically line set and line scenes, and eliminated them as core data. But unfortunately, line scene uses scroll positions. Let's see if we can find out where the old one is. That's line set, line scene. Yeah, see how hard it is just to figure out what file we're looking for? Scroll positions, right? It's got an array of these things. And it was really problematic to have a non-core data class object referencing, having a child that wasn't core data. So I was refactoring that and getting rid of that, and it was in the process replacing all the code that references it and uses it. And in order to do that, I needed some Kotlin-based functions here, which pull out the properties from the dictionary. So the original core data class, so let's look at that again. Scroll, well, that's legacy, that's not dead, this is dead. Here's dead. There's not a lot here. There really are only two meaningful attributes. Attribute is really the same as property in an OO sense. A Y position and a time. These both come across in the JSON. I don't know if I have a printout of that. I don't think I do. No name, is this guy? No, this is a different one. These are just, these are dumps from the backend JSON. But actually, let's just go ahead and run the program, and we can see where it's actually using the Kotlin stuff. So if you weren't aware, in order to build a KMP project on the iOS side, it has to first compile obviously anything in the shared module. That's what this REH, the RISHA, Rehearsal Shared module is. And it has to compile all this into Kotlin, generate this Objective-C file before it does that. Now you can actually build iOS from Android Studio, but honestly, are you going to debug it from here? Are you going to be able to use any of the intelligence that Xcode provides? I mean, don't get me wrong. Given a choice, yeah, I'd prefer to use Android Studio over Xcode. They both have their awkwardness, but given a choice, yeah, I think JetBrains and puts a little more effort since they sell their product into actually making a usable IDE. I'm not a fan of IDEs. I only use these because I have to. Most of the time, I prefer to stay command line and editor. But Xcode is well regarded as a very inadequate tool, probably because development tools are just not Apple's priority. Apple is about the end user. They support developers, it seems, as reluctantly as they have to. They don't really focus on developer productivity. That's not their thing. I'd be surprised that people inside Apple really use the tools. I just doesn't feel like somebody who eats their own dog food made this thing. Now, I could be wrong. Maybe my awkwardness with it, but yeah, not a fan. As you've known, if you watch the videos, I gripe and moan about it all the time. So I'm sure you'll hear more of that if you decide to keep watching. Okay, where were we? Sidetracked. Right. Let's just run it. I prefer to, I do the build from this side. The build of the shared module is quite quick, typically. Although, why is it taking so long in this case? Oh, because I start up Android Studio and it's a first time build on the emulator. Are we on the, oh, no, I'm sorry. It's trying to build the rehearsal side. I'm sorry, the iOS side, I just picked it. And I think this will actually fire up the simulator. As you can see, there you go. It's doing Xcode commands. So it actually built the Kotlin code in the shared module and then went out and started running the Xcode build cycle from the command line. And yeah, it does work. And it does start up in a separate instance of the simulator. Okay. Android, they call it an emulator. iOS, they call it a simulator. It's the same thing, but of course they use different words. I think emulator is a more accurate term. Yeah, so we don't want to run this one. Let's stop it and kill it. And if you see the Android version has no front-end UI. Like I don't have any of the images. I have the menus as just placeholders. There's almost nothing there right now as far as, let's build it in fact. You'll see there's almost nothing there in terms of UI. And there's a reason for that. I may not cover that today, but when we get around to it. Okay, so here's the emulator. Let's get rid of that. Get rid of these pop-up messages. And we're running on a Pixel 5 emulator, API 30, which would be Android C11. 33 is 13, 32 is 12, 31 is 11. Is this, no, 29 is 10, I think. I can never remember. And we can say stay logged out, log in existing account. Yeah, these are just placeholder using Compose. And there's no graphics, there's no real structure here. It's just making sure we have the basic outline. But we're not really building the UI on the Android side. We're building the internals, because what we're doing is we're kind of replacing the guts right now of the iOS app, and replacing it and rewriting it. And a lot of the internal logic has already now been rewritten on the Android side without even having a front end, a really working front end from the Android side. And that's what we're looking at here. So I'm starting to move the domain objects from iOS to Kotlin so they can be the same code shared by both. And that's why it's domain. So if we actually look here, we'll see, look at that, single file called domain. All the existing domain classes right now are currently in here. And when I say classes, this is a class. This is a data structure used for testing. I actually wrote some UI tests that are multi-platform here. When I was the first few days I was working on this project, there were some issues with a large number of scripts. So I wrote some stress tests that would generate hundreds, if not thousands, of fake scripts to test the load, and some of this is work from that. So I just kept all that in the same file. But instead of having dedicated class definitions, all the domain objects, they're not even dedicated data structures. They are dictionaries. And a dictionary in Kotlin is simply a map. A map is just another term for a dictionary. In Swift, they call it dictionary, which I think is the better term. When you do a lot of functional programming, you'll see the word map actually means something different than the container that is a map. It's an unfortunate container. Sometimes people will call it a hash map, but a hash map technically is an implementation of a dictionary, right? So all a dictionary is, it's a collection of name value pairs. It's just saying you have a collection of values that are keyed in some way, and a dictionary is typically the key is a string. So if you look at a dictionary on the Swift side, they actually have a dedicated dictionary class. In fact, let's go to domain here. And well, yeah, this is the syntax for any dictionary. It tends to look like it's an array, but the left square bracket, the right square bracket, separated by a colon, the key type is indicated, and then the value type is indicated. So as you can see, it is not technically an array. even though they're using the array syntax, there's no guarantee that there's a sequential order or that it's a contiguous block of data. I think you just look at this as this is a collection, and the type of a collection in this case is a dictionary noted by the colon in the middle, in which you have the key type and the value type. So it's a collection of key value pairs, also conventionally called name value pairs, NV collection, NV pairs. One of the downsides of our work is that there's a terrible number of synonyms for the same concepts all over the place, especially when you're crossing languages and crossing platforms. You're going to see, func here, which is really a procedure, and it's fun over here. And if you're in Rust, it's FN. And other languages, if you're in C, there's no name for it at all. It's just a type with parentheses and a name. C++, same thing. Okay. Where were we? I get sidetracked. Dictionaries. So these domain objects are just dictionaries. They're just named value pairs. Why? Why don't I make a specifically typed structure for that? Well, because it's not necessary. And the bona fide data that this application, Rehearsal Pro, let's go ahead and run it here from the, actually, let's do the build that I already did the build here, right? In fact, yeah, so what I do is I build the Android app. That forces the build of the shared module. And because the build on this side, because there's not much of an app there, it's just so quick. You can see it comes up almost instantly. So that builds the shared module. Then when I go to build this, it's actually already running in the simulator. I'm going to bring the simulator back up. It builds pretty quick. All right, so this is the application. And Rehearsal Pro is an application specifically for actors, mostly working actors, or any actor. I've done a little acting in the past, not a working actor, but it's a great app for practicing lines, for rehearsing. That's what it is, Rehearsal Pro. But I'm not going to go through all the details of this app. But what I want to say is that most of the data in this app is binary data. It exists in the form of PDFs. This is a PDF. It's binary. And in some cases, there's audio in here and there's video. You can actually record yourself on your phone and on your mobile device rehearsing, and you can capture the video and you can capture the audio. So the bulk of the data is a binary data anyway. Right, it's a binary blob. You're not going to make a class definition that represents the PDF. It's going to be treated as a binary blob. The actual informational data is mostly metadata on top of this. Right? It's descriptive data of the binary data. When people say metadata, that's an awfully used term. But if you think of for example, a web page, they'll call the metadata. It's not the content that the user sees, but the hidden behind the scenes informational stuff that's easy to interrogate via programmatically via scripts and search algorithms and things like that, ways of describing what you're having. And that's what you have here is you have metadata. And this metadata and the binary data is stored on the servers for the users. Let's go back to the app. And it's stored, however it's stored in a relational database on that side, or it doesn't really matter. It's a black box, it's opaque. But when it's retrieved from the back end, it comes across as JSON payload in REST calls. In this case, post calls. It could be post or get. For the most part, they are back-end API calls against a REST API, and the payload comes down as JSON. For the metadata, the other payload just simply comes down as binary. So it comes down as JSON, and then what happens is the original legacy app would convert that to these dedicated core data objects, right? So you can see, for example, beat marker here. Well, let's take something more substantial. Let's take a look at script. And script JSON, somewhere in here, you're going to see a definition. Where is it? It's hard to find. Script. Core data properties. Somewhere in here, you're going to see a bunch of keys. God, I can't even find it. Okay, let's look at the dead stuff. That's easier. Let's take a look at line scene. Line scene JSON. No. You see how much code there is? All this code, by the way, does very little of actual meaningful work other than convert data from a JSON format to an Objective-C object format, right? So there's 2 points of conversion. It comes from the backend as JSON. It gets converted into this object format. That then goes through the core data ORM to store into a local relational database. I mean, in defense of the app, you could say that when something's created locally by the user, for example, let's say they create a new line set or they create a new scene, that's created in Objective-C / Swift binary language format, right? As data, in the case of Swift, it would be a structure or a class or an instance of a class. In the case of Objective-C, they don't have structures, so it's only an instance of a class. It's only an object. Then that has to be marshaled into JSON that's pushed in the backend to be saved, and then later retrieved by JSON and converted back. So I look at the server side, regardless of how it's stored internally, as the bona fide representation of the persistent state of these domain objects. Why not just keep them in that JSON format? What is to be gained by converting them to this structured object-oriented format? Nothing, really. That's kind of the conclusion I came to. It's a lot of unnecessary work. And that's why all this code, at least the stuff you see that's core data stuff, is all now in the dead folder. And it's been replaced by effectively this, right? It's been replaced by effectively a few functions in Kotlin for each thing. And here's, you can see, for example, here's line scene, here's line set, and now scroll pause. And this is the actual mapping. I copied this from the Objective-C file, and I don't even remember which file it came from. And I copied this over for documentation purpose. Inside the dictionary, these are the keys that identify the attributes that you see mapped here. So rather than create a class and create an object in memory, I just keep the original dictionary that we got from the back end, and I provide functions to just extract out the parameters based on these keys. That's it, right there. Oh, you want the audio file name? Okay. Find the one that's NF. Oh, you want this? Okay, find the one that's NA. You want that? Okay, ND. Right? What is to be gained by converting it to this? Performance? There's not, we're looking at tens of files being dealt with at a time, maybe hundreds. On devices like this, the time it takes to do a lookup in a dictionary is nothing, right? If we were back in the 80s or something like that, it might have made a difference to convert it to binary, but this is not pushing a high volume of data back and forth from the UI to the user or even to the back end. I would say the greatest volume of data is the thing I'm working on now, the scroll positions. There's literally hundreds of scroll positions. So we can actually measure the performance of now keeping the scroll positions in its dictionary format rather than converting them to an internal binary array of doubles, which is what it ends up being. So that's what we now have. We replaced all that core data with, well, here's domain line scene, 1, 2, 3, 4, 5, 6, and that's it. These functions. And the only reason there's anything on the Swift side under domain is because I had to make these facades, right? You can see it right here. There's line scene. This facade is only needed to access the Kotlin functions here, right? There's not even a data structure. These are just, this is an Objective-C class. This only has to be a class because Objective-C cannot call top-level functions outside a class definition. So a class has to be made. This is in Swift with the annotation, make it compatible with Objective-C. And all this does, you can see it's a stub. right? Because I can't do this straight from Objective-C, even though Objective-C is the mapping that's created. See how complex this is. There's a lot going on. There's 3 languages here. It's Kotlin, generating Objective-C, that Objective-C header being accessed through Swift or from Objective-C itself. So there's domain line scene, and here's the code that replaces. And that's a lot of code here. And again, this is not really doing anything from a feature standpoint other than dealing with the ORM. And the ORM is supposed to save work. The ORM is supposed to make it transparent because core data sits on top of a MySQL database, or sorry, SQLite. So is this helping us? I don't think so. That's the rationale. Okay. So let's see where we are. Let's run this. Most of my work here in rewriting this is retrofitting all the code that uses the line sets, the line Cs, and the scroll pauses. And where it goes out and tries to touch these dedicated Objective-C objects, it's now delegating into Kotlin. The Kotlin with this functional approach and this more dynamic approach. All right. Actually, I think we were just dealing with scenes at this point. All right, these have all been downloaded. So if we click on that, we're gonna hit some breakpoints. Oh, we crashed. Crashed on scroll pause. Okay, this is what we want. This is where I just left off. I was rewriting the stuff in scene. So eventually scene is still, this is not line scene, this is scene. And that's a whole nother story if you watch the previous videos. There's a few core data classes that I'm leaving in place because it's just as big of a chunk of rewrite this is. I wanted to do this incrementally. So instead of replacing all of the core data, I only replaced some of it. In this case, 3 classes: line set, line scene, and scroll pause. So scene, which is almost identical to line scene, and script, which is kind of the top level parent class of everything else. Everything begins with a script. These are still core data. They're still going through ORM, and I'm trying not to rewrite any of that code that I don't have to. I mean, the basic rule is if something's working, don't mess with it. Just try to retrofit what you're doing in there and make the least amount of changes. But as you'll see, there's a lot of changes going on here. So let's go back to where we crashed here. Let's get rid of this side window because it's in the way. And we're in the debugger. We had the debugger here a second ago. Where is it? It's there. There we go. Yeah, so I've got to-dos scattered all over the code, and I'm catching up with the to-dos and rewriting and replacing. So as far as I can tell, most of the stuff is done correctly. So what's failing here? Okay. So this is an example of the rewrite. Originally, so the scroll positions, the scroll pauses, it's a array of basically 2 values, 2 doubles, a y value and a time value. And here this is a request by the scene. It's an extension on scene. Yeah, I don't even want to get into that. Extensions. The original code looked like this. Points is in fact, let's just see where points is, because that was rewritten. There we go. And we're crashing here. We'll see why we're crashing. Some kind of a nit. Let's go back to points. Oh, here's the original points. So points was an array of scroll positions, and this is a retrieval. Well, this is a variable, and this is the initializer of the variable, and this is an extension on scene. So I'm assuming this is Swift. So keep in mind the scene class is an Objective-C class. This extension is on the Swift side. So extension is adding methods and adding properties or variables. In this case, I'm assuming that, let's see, I'm not assuming anything. This is probably just an accessor. I don't know if it's done lazily or not. Anyway, let's look at dict. Can we look at dict? No, probably not. Pdict. Oh, it's breaking there, not there. Let's restart it and put a breakpoint there. This is where it's crapping out. I know, we're on the iOS side, but that's where we're debugging it. Even though it's using code on the Kotlin side, we're on the iOS side. Okay, dict from nsdict. Oh, this is a function that I wrote, and it's actually pure, believe it or not. It's in conversion. And the reason I had to write this is for some reason, I can't get in Swift code. So this map string any, Kotlin automatically makes this compatible with an NS dictionary. In fact, let's see if NS dictionary is in here. Yeah. You see, there it is right there. Everywhere I use map, it uses NS dictionary. And you can see string and ID is just, because Objective-C is dynamically typed, right? ID just means that's their any, right? This is a string any. So this identifies the class and object that actually corresponds to. And it always throws me off using the star because coming from C and C++, we think that's pointer. A reference in C++ is an ampersand. But in Objective-C, this is a reference because everything is an arc reference. It's automatic reference counting. It's not truly a pointer, even though it looks like a pointer from a C standpoint. NS dictionary. So in the Objective-C code, I can go back and forth between the Kotlin map and the NS dictionary without any trouble. And what's really strange, let's go back to where we were. So where are we? This is Swift code. In some cases, it automatically takes care of mapping string any to NS dictionary, but it won't without this conversion. If I don't do this, it's going to give me it's going to complain. And I'm trying to remember which way is the problem. Yeah. It's gonna give me a type problem. Watch what happens. Compiler doesn't like this. So the type of dictionary in Swift should look like this. String any should match NS dictionary, NS string to ID. But Swift doesn't dig that. It doesn't like that. It says it's any hashable to any, even though this is NS string, right? It doesn't think, for some reason, if we look at self scroll pause, and we're extending the scene class, and the scene class is in, it's going to be here, is in Objective-C. If we look at scroll pause, which is type deft to NS dictionary. Now merely a dictionary. Used to be its own class. Its class is gone. It's been replaced by a dictionary. So you can see scroll pause is dictionary pointer, which should, right, pointer to a dictionary. Now it doesn't specify what type of dictionary. Huh. Maybe if I do that, I don't need that conversion. It said any hashable. Maybe that's the problem. I'm glad I'm explaining this to you because maybe I can solve my problem by doing that. Can I do that? Okay. Okay. Yeah, nice. I'm glad I looked at that. Okay, so I'm going to fix the type defs for line set and which are in script. They're in script as correlated class. Yeah, nice. Yeah, good, good. Now merely a dictionary. Great. Let me double check and see if I have any other locations for that. Well, I can get rid of that converter that's not even working properly. So here's where I can do a find grep. And I want to search everything where I say, these are parameters which tell me to show the source, where I say type def NS dictionary. So it's Objective-C generics, templates. Oh, see how slow it is? Because it's at the top level of the project. So it's going through all those binary files. And I don't have to specify source extensions. So just by popping down into the source directory, which only has source, look at how much quicker this is. Okay, there we go. There's another one right there. I gave each dependent file its own. Yeah, so we need to do file helper.zip. Now I could make one type def and just call it, I guess I could do that, just make a single type def, but then you've got this common header file that everybody has to include. And then you've got to go look up what the type is. When you're using the same type over and over, or the same type signature, in this case, generic type signature, just in the past, I've overly aliased everything, over aliased and over abstracted everything. So now I'm trying to be a little more, I'm going the opposite extreme and trying to be as direct as possible. This is going to be an experiment in my mind to see which is the better approach, or there's some happy middle ground between them. That's why on the functional side, I'm really pushing the envelope to be as functional as I can with currying and partial application. And so what I'm doing is I've been so far in the extreme on the object-oriented side, the most abstracted, the most aliased, the most objectify everything, classify everything, to the other extreme to see where the balance point is. All right, file helper. File helper, where are you? It says right there, UI app. I don't like that. That's a red flag. Something called file helper is dependent on the app, just like the God object. And we're looking for a file helper zip. There it is right there. So see, what I was saying is if I put line scene type def as a common type def, then suddenly I'm now depending on this other type, this common thing, common headers, which is the typical approach, right? Is put everything in common headers, but then this is that locality of behavior. Well, not just locality of behavior, the locality of declarations. You're constantly back and forth to where's that common header? I got to look at that to see what the thing is. And If I want to replace everywhere there's an NS dictionary within a string, I can just do a global search and replace. So there's not a lot of benefit to aliasing, because that aliasing hides information. In fact, that's the purpose of abstraction, is to hide what's considered unimportant details. But I think knowing what type of dictionary this is an important detail, knowing its exact signature. So I don't want to hide that. In fact, this type def in and of itself is hiding details, because anything that refers to line scene is this. But the only reason I have this type def in here rather than just changing everywhere it says line scene in dictionary is because there's so much legacy code referring to line scene that, again, I wanted to break or not have to rewrite as much as I can. With all the to-dos I have, there's a lot of code that's breaking. This is a temporary, or this is an intermediate step. And all of this code is going to go away anyway. It's all going to be replaced on the Android side, on the Kotlin side. It's all going to be represented on this side. Both the UI, I am doing the UI on the Kotlin side as well, not using Compose Multiplatform. I've got my own approach called unedited, which is a way of doing all the UI in Kotlin, and it renders on both sides. I've already used that for some new UI that I've dropped in. That's what this is here. This is a Swift implementation of my UI Nota. It stands for UI notation, and that's a whole nother story I may get into at some point. Another experiment. I like experimenting. This is in the place of using Jetpack, using the Compose approach, the Compose Multiplatform. And there's reasons for that. You may not think they're good ones, but they're my reasons. So let's do a search again. So everywhere we have dictionary, we now have the full type signature, since NS dictionary is a generic, right? It's obviously a generic. That's what we're seeing here. And that means I don't need this conversion. This is stupid. I don't even like the name of it, dict from NS dict. Let's get rid of that. And go back to where we were in the debugger. Oh, did we stop? Are we still there? Oh, it's on one of these threads. Let's. Okay, we broke something. Oh, here we go. This is not a fun error. I've seen this before. This is the problem with changing the way something. Oh my God, I hate this. Yeah. See this right here? Compiler error when using type aliases. Anti-hashable. Well, maybe I can now use line scene. Maybe that'll solve the problem. Maybe that fixes this. Does that fix this? No. Okay. Oh, yeah, this is not fun. Compiler error when using type aliases. Let's try going back to there where I just specified it as string any. Oh, I didn't replace both of these. I could have replaced both. Let's try. No, it didn't like that. It didn't like it. I did that on that line. It's going to work? It's going to work? Yes. No. No, I got an error. Look at that. This is what's great about Xcode. I get an error and it disappeared. Where's my error? Okay. Good. We don't need this. How many? Does that not look right? I see 1, 2. Okay. I'm just looking at where the close of this. Yeah. Okay, go domain scroll map or that. Is that a little more readable? Should we indent it? Like that. So we're calling this function domain scroll pause list. We're getting the result of this. Oh, by the way, there you go. So you're looking at the Kotlin directly. So this is Swift code. I don't have to go through any facade or stub. I call straight into domain scroll pause list, which if we look at the header, domain scroll pause list, domain scroll pause list, lowercase d. This is why I get rid of the, I tend to omit the first one. So you can see there's domain scroll pause list, and it's in the interface domain KT, which has a Swift name alias, which gets rid of the prefix that they added. This is namespace scoping because Objective-C doesn't have namespaces. You don't want name collisions. So it finds it there. And if we look at the actual original code, domain scroll, this is all sorted alphabetically, so we should be able to find it easily. There it is right there. This is the code the programmer, me, I had to write in Kotlin, right? It's in the file domain KT. The KMM code generation cycle pass, compilation build pass, it's called build pass, code generation. It generates this declaration. So you're looking at it from the Kotlin side, it looks like that. And this is how you access it. So Kotlin, it looks like this, domain, stent, top level function, no classes, no methods. Dictionary is a map string any, index is an int, returns a list of any. Here, dictionary is the Swift equivalent of the dictionary, which matches exactly Swift string colon any matches NS string thing generated. So when you're on the Swift side, it's a little less painful than on the Objective-C side, which is funny considering it's an Objective-C interface. Now, I heard something about KMP, them supporting Swift code interface directly, but I did update recently, was it recently, a month ago? I upgraded to the most stable version of KMP. This isn't the latest Android Studio. Where is he about? This isn't the latest, this is Giraffe. It's already a couple generations back. I think the current one is I, just got released. Right, so this is G, H, I is the latest. But I'm pretty sure the plugins, where are all the plugins? These big IDEs, it's just hard to find anything. I think we go to settings, plugins, and KMP. And if there was an update, it would be telling me. So this is the most stable one. I mean, there's newer beta versions, but I don't like using beta anything when it comes to development tools. There's SQLite when I was thinking of just doing the Android version of core data. I'm like, nope, I'm not going to do that. I don't need it. I'm not going to do it. That's the very first episode of this series. If you go back there, you'll see, oh, I'm going to use SQLite, and it's going to allow me to make this portable version of this ORM that maps to SQLite. And then I realized, why am I doing that? I don't need to do that. It's a hamburger. Okay. So I haven't got a lot of work done. I'm spending most of this video explaining things to anybody listening, so I hope you're appreciating it. All right, so dict, right. Oh, but I did make this fix, which is a good one. I don't need this stupid converter. All right, let's see where it's breaking. Let's find out why it's breaking. Maybe getting rid of the converter helped. Okay. My fake iPhone 15. It's a big phone. All right, scene one, take one. Yeah, we can get rid of that. So we don't need any. I'm going to restart. Find this super annoying. Do I have to say return? Can I say equals? I bet I can't say. Well, maybe I should be. That should be legitimate Swift syntax. I don't think I need the block. Now, I don't know if this is executing lazy or this is an extension. No, it doesn't like it. No, doesn't like it. Yeah, look at that. Cannot use instance member self within property initializer. Property initializer is run before self is. So that's interesting. But if I do it like that, it's not a problem. So I'm guessing that this is an accessor method, meaning this execution is lazy. If I put the equal there, it's happening at initialization time. This doesn't happen until it's requested. Just like in Kotlin, you can redefine the default get and set methods. Yeah. Well, it doesn't need to be on 2 lines. Okay. Let's see what's going on. All right, go. Boom. Done like that. Scene scroll pause. Oh, here we go. Load dictionary array, first object. Is it empty? I'm guessing I can't call first object. Doesn't return null. Where are we? We're in Objective-C. Let's see what NS dictionary. Let's see what Apple documentation has to say about that. Throw an exception. You would think under Objective-C it would return no. First object in the array. If the array is empty, it returns no. But that's on an array. Or let me guess, NS dictionary does not have a first object. Wait a minute, this is an array. Wait, this is an array. Load dictionary array. All right, well, we're gonna have to do put some debugging sandwiches in here. We're in Objective-C, so what do I have to say? I have to give it a type signature. What is the type signature here? It's scroll. Wait, no, this is an array. Wait. Scroll pause. Oh, scroll pause is not an array, right? Okay, so I have to say scroll pause. Pointer. right? Is that how you do an array? No, you actually have to say array, right? Oh, God. Ah. Load dictionary array should. Let's see what there we go. Well, this is the Swift signature for that. All right, let's look at what it looks like according to. Stuff's all over the place. Where's that file? Oh, I might have to go. I might have to conclude this video for now. Sorry, there we go. What are we looking for? Oh God, my windows are popping up all over the place. I've got to figure out a way to do this multi-window stuff a lot better. Load dictionary array. It's helpful to look at this header so you can see what the actual signatures are. That doesn't exist? How can that not exist? Shared load dictionary array. No, sorry. Oh, that's my own function in here. Yeah, there you go. It doesn't even call that. It calls load files to strings and it converts strings to dictionaries. So again, it's returning this. Well, convert strings to dictionaries, which is a local, so it's conversion. Again, we keep coming back under this thing. There we go, strings to dictionaries. See, this is what it looks like calling from Objective-C, but I don't know exactly what that looks like in Objective-C. So when I actually go to declare a local variable, what a pain in the ass this is. Where were we? God, got all these files I have open. I haven't, you know what? Let's just close them all. Just close them all. Just close them all. Stop. Let's go again. It's too confusing. What a mess. Oops. Oh, right. All right. Compiler will tell us where we were. An array of this. I don't think it's this. Let's just call it A. That's not going to work. Yeah, it's like a pointer to pointer. Pointer to array, array of. Come on. Let's just do a fine grep. Because I don't want an array of scroll pauses. Let's get out of here. I have to get an array. Wait, scroll pauses. Load dictionary array. What the hell am I thinking? Oh, a scroll pause is a dictionary. That's right. Yes. In fact, let's look at .h files, .m files. Array. Mutable array, NS array. Okay, that's what I'm missing. NS array. Oh God. So NS array, scroll pause. A. Yeah, okay. I'm just doing this so I can debug the damn thing. All right, then this is a first object. This is tedious. This is what I mean about middle programming, right? This is not any kind of meaningful logic here. This is just, I've got a map, I've got to figure out how to deal with this type as that type, but not as that type. Or a first object. This is an array, and it should come back as nil. And if it's not, I get an empty dictionary. Oh God. Let's do scroll pause. Maybe that's the problem. I don't think so though. Use of undeclared identifier. We're in Objective-C. There's no let, there's no var. It's just a name. Oh my God. Looks like that. Come on. Looks like that, right? Oh, is it the parentheses that are the problem? Do I have to do this? Is that the problem? I guess so. Yeah. Ah, man. Jumping between three different syntaxes. Expected. Oh, do I need a semicolon? So you don't in Swift, you do in Objective-C. And this is wrong. Expected identifier. What's missing? We need the object. Yeah, God. Expected identifier. What? 1, 2, 3, 1, 2, 3, self, scroll name. I've got too many of these. Call, shared, forgot. Yeah, okay. Got too many of those. There we go. Whew, all that work just to get here. I've really been enjoying programming in APL, by the way, and BQN. Man, it is a breath of fresh air after doing stuff like this. All right, hey, let's see what it looks like. Swift native NS array with something. No, you got no idea what it is. I'm not going to tell you what it is. See, that didn't help us. Empty array. So calling first object on empty array, I'm assuming is not going to throw an exception because it said nil. And here I've got my Elvis. It says, if you give me a nil, then just give me an empty initialized guy. Oops. So let's see what happens. Now. Wow. You saw the documentation. We both saw the documentation, right? Where was it? First object. Right here. It's not supposed to throw an exception. It's supposed to give me nil. The array is empty, returns nil. Now, this is on an array. Maybe that's not the same as NS array. Give me NS array. Come on, here we go. First object. It's going to say the same thing. Yeah, it's the same thing. So why is this failing? Let's try again. Say SP, scroll pause, star. Got to put it in parentheses this time. Right. No. Doesn't like that. I've got to do it like that. Right? Equals first object. So how about if we say if SP equals nil, right? God, I wish I had Vim bindings in here. Using the mouse and the keyboard together, it's super annoying. I only have myself to blame, not taking the time to set up something differently. What is going on? Why are we throwing an exception? Now, you'd think I could use a ternary in here and not have to repeat that, but breakpoint, 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 breakpoint. See where it's blowing up? That's not what I meant. I meant to say SP. No, does not equal no. Start again. No idea where this thing is breaking. All right, we know that's not the problem. So it's blowing up on this. Okay, why? Scroll pauses in its dictionary. If I say in its dictionary init, why is that a problem? Well, this is going to have to continue. I'm getting a high priority interrupt. Why is this blowing up? Do I not understand something about a init? I just want to create an empty dictionary. Isn't that how you do it in Objective-C? I'm missing something. Run again. Not an Objective-C expert. Don't want to be. Step in. Well, it's just like, no, you can't do that. Init. What's the error? There is no init. Object is kind of class. Wow, look at all this stuff. What a mess. I'm guessing there's no init. Apple's documentation, not a fan. All right, well, at least we know that's working. In its dictionary. Oh, it's slow. Do I have to say init with objects? Init, init, init. Initializers. God, they make this so complicated. Init. Creating an empty dictionary. I could just say dictionary. What's the difference between these two? Oh, this is a class method. Oh, right. This is okay. See, I don't know my Objective-C. So the minus means this is an instance method and this is a class method, right? So I'm doing a creation, a factory, a construction. I don't have an instance yet. I'm creating an instance. Init is meant to be called on an instance after it's been allocated. I forgot that there's this like alloc. You make an alloc call and then you init after the alloc. It's extremely tedious. For something that has automatic memory management, and I'll give you that. It's not garbage collection, but wow, they really made it painful. So really, I just want to say dictionary. So we see that. And notice the calling convention. There's no distinction between instance level and class level. You just have to know that from the method. This is a real shortcoming in the syntax of an object-oriented language. And nothing here tells me I'm making a call to the class versus I'm making a call to an instance. Well, yeah, this is the class. So meta instance. I guess that does tell me that because it's not an instance. Okay, I take that back. But it's weird that I could call init on the class and it didn't give me a compile error if that's the signature that we're looking at. Let's take a look at this. Mutable subclasses. If you don't want a temporary object, you have to create an empty dictionary using alloc and init. So you've got an alloc and then you've got an init. If you don't want a temporary object, so I guess I got to do the alloc thing. Yeah, there's already a ton of code in here that does that. Let me see what the alloc signature looks like. What? Oh, -m probably. Yeah, you got to go alloc and then init. So you say alloc and then init. Look at how much syntax is required to create an empty dictionary. That's a lot for something trivial. At least I'll give it to Swift fix that. Because remember, I just put you can just put the two brackets with the colon inside, and that just means give me an empty dictionary. At least they did fix that. Okay. So let's go all the way back to what we wanted. Obviously, this is the problem. We can fix this. We don't need all these intermediate variables. Just don't like this syntax. So we get that. We then call first object on it. Right? Then we use the Elvis operator. And then we do that init. All that crap goes away. So this is a lazy initialization of the scroll pause member of the scene class. God, this is so ugly the way this lays out. One, two, three, 1, 2. Yuck. First object is one word. So now it should work. And then I'm going to stop. This will be the end for today. So this video was mostly explanation. If you're still watching at this point, hopefully you appreciate my efforts there. And let's see. Let's just get this far. Boom, fix that problem. Okay. That was it. I did an init without an allocate. And the compiler let me get away with it because this is dynamically slash statically slash pseudo-statically strong type, dynamically weak type, something somewhere in between. And we get to here. So where do we go from here? And then we try to get a double value. This is all that weird Kotlin double is not a true double. And that thing is nil. So we get a nil. We use the question mark. It's not there. Right, because this comes back as nil. And the item is nil. The list is not nil. The list is nil. Why would the list be nil? I'm going to have to debug this stuff. But it'll default to 0. Curious as to why domain scroll pause list is coming back as nil. That shouldn't be nil because if it's nil, what? It should never come back as nil. It should come back as empty. Doesn't it? Didn't we just prove that? If it's nil, how did that end up being empty? Hello? If it came back as nil, we get a new one allocated. Can't be nil. And why can't I see it? It's a dictionary. I'm confused. Points, return, self, scroll, pause. Oh, the call to the Kotlin side is returning nil. So I got a dictionary of points, and I'm saying, give me the, oh, right, because if we look at the Kotlin code is expecting this to have this top level tag scroll pause. Instead of just directly being an array, it's got this name value pair in which the value is the array. And because that's coming back not found, it's coming back as nil. I don't think we want to do that. Because when we actually go to add scroll positions, we need this key to be in there. So I guess I have to do a knit with objects on NS Dictionary. It showed us that, right? This is NS Dictionary. Isn't there in a knit with objects for keys? Is there an example? Can you show us an example of this code? This really awkward part of the syntax is you get this as the description of it, but you got to know to put it in brackets. It doesn't look anything like that when you actually use it. And knit with objects for keys. I have to give you an array. And I give you an array of keys. Wow. It's not easy to write code from that description. They should at least put an example in there. If I go to standard C++ on the web, for every part of its API, for every part of the description of the language, and I'm going to see sample code. Why is there no sample code here? This is what I mean about Apple. I mean, look at this website. It's this big, blocky, kind of marketing-based sort of style. Look at how much space it takes up. Look at how much scrolling you have to do to find things out. And it's described in not a way that sounds like programming. This is some visual designers thinking this is a cool way to do this. And then the rest of it is mostly links to Apple stuff. This is not developer-oriented. It's called developer. It's not made for developers. This is clunky. Not my opinion. All right. What's it called? A knit with objects. A knit with objects. Do we have an NS dictionary anywhere? No, it looks mostly like all NS arrays. See, a knit with objects. Let's see if I can do that. Wow, this is ugly. Ugly, ugly, ugly. Back to where we were. Let's just restart it. Sometimes it's faster just to have it take you right back to where you were. Okay. And there we go. Init with objects. And according to the documentation, I have to give it an array. See how this is in parentheses? This is not in parentheses, or this is... All right, so this is an array of objects. In this case, the object I want is a scroll pause. Wait. No, what is a scroll pause? It's an array of... Oh, God. Look at how painful this is. The actual dictionary entry, if we look at the Kotlin side, it's list, by the way, in Kotlin Multiplatform gets mapped to a NS array. If you use array here, it doesn't map to NS array. So list of any. It's going to be an empty list of a list of an empty. Crap. Wow. Wow, look at how tedious this is. I literally have to say this. NS array alloc. No. How fun this is. NS array of NS array. Actually, I don't think I have to say, I think I can just say NS array alloc. I think I can do that. But now I've got to do the init. So that makes an empty. So init with objects. And then what was this documentation? 4 keys. I wonder if there's a 4 keys in here anywhere. I was going to stop, but I'm not. Yeah, nobody's done it. No examples. Okay. Wow, I hate this indentation. I'm complaining a lot. 4 keys. See how it's just like to get it to line up? It's just terrible. It's bad. And then we're going way off to the end of the line here. Yuck. Yuck. Can you read that? I can't read that. And what the hell is this? What? God. 4 keys, and it's an array, and I've got to use the @ sign, and I can say scroll. Yeah, without that. What do you think? What do you want to take bets on whether the compiler is going to let me get away with this on first try? Let's see how well I can do this. So looks like I've got too many. So scroll pause alloc, init with objects. These are the objects. It's an NS array alloc with an init. These are the keys. Do I have too many? No, it looks right. What do you think? Is that readable? Is that followable? Not really. I almost feel like I should do that. Oh, God. You know what? I'm not going to be living with this code for a long time, so let's see what happens. See if the compiler gets by. Okay, what's compiler? It's compiler. Expect identifier. Expect identifier. 1, 2, 3, 1, 2, 3. Huh? What? Something along this line it doesn't like. What don't you like? Okay, I'm gonna keep chasing this for a while here. Init with objects, 4 keys. Init with objects, 4 keys, objects, keys. NS array. SRA of any. Well, no, I see plenty of NSRA. Yeah, see, there's one right there. Init with objects, NSRA, alloc, and init. The only difference is this has 4 keys. Let's see what happens if I get rid of 4 keys. Compiler should complain. Expected. Okay. Yeah. Yeah, init with objects. Okay. So it's able to compile that through. Okay. So what am I doing wrong? 4 keys. What am I getting wrong here? No idea. Compiler is just not helping me. Expected identifier. What? What identifier? What? What? Do I have to put this in there? But I'm saying 4 keys, NSRA. I mean, I don't think I need this in here. I can say NSRA, NSRA, because I know that's what it's going to be. Oh, wait. Yeah, I don't think I need to do that. Is it the ampersand? It's not the ampersand because that's what you've got to do to put a string in there. Wait a minute. NSRA ID copying. NS dictionary, 4 keys. Good old Stack Overflow. 4 keys, keys. Oh, I have to do that. Swift equipment. Well, I'm not in Swift, dumbass. That was harsh. I have to do this. Is that what I need to do? Needs that extra ampersand? Is that going to work? Expected identifier, when what was missing was that. It's not a very helpful compiler. Okay. Fun. So now at least this should not be no. Oh, barf. Knit with objects. That failed. No. Knit with objects failed. Here we go again. We go there. We go here. Knit with objects. NSArray alloc init. 4 keys. I have to make an NSArray of an NSArray. Right. Yeah. I got to do that. Okay, I have to say at. Oh my God. Look at that. Look at that. To create an empty dictionary, this is what I've got to do. Well, it's not an empty dictionary. It's a dictionary with one entry, which is an empty array. That is tedious. Wow. Okay, here we go. We going to get through it? Yes. So finally, K-list is 0 values, but it's not nil. Yeah, an array of any that's empty. Okay, item should come back as nil. All right, I'm done for now. That's enough. I gotta go. I got other things I gotta do. Okay, thanks for watching if you made it this far. I hope it was informative, and I hope, even though, again, we're back on the iOS side, that I showed enough of the Kotlin side for now. Some point in the future, we're going to see a lot more Kotlin programming and a lot less iOS programming, hopefully. But as you're doing your own Kotlin multi-platform project, I wish you the best of luck.